Welcome. In this tutorial we are going to learn about array. Array is a sequence of elements where each element is of same data type. So earlier we saw list data type which was holding different kinds of data type. It is very similar to the list but with the type restriction. Both the data type contains similar functions. They can be iterated over, the comparison operator, slicing, indexing, all of the functionality works same as the list. But when we are storing an element or when we are creating an object of array, we are defining a data type of elements that array is going to hold. So you can only insert, update or delete that type of data to the array object. So here is the list of data types and its symbol that is used when we are creating an array object. So here is the list of C data type and their respective Python type. This is the minimum size in bytes which will be used to store an individual element, and it varies depending on the platform. So it may require more bytes to store a particular element. That depends on the C implementation for the specific machine. So here we can see the symbol small I for signed integer, capital I for unsigned integer, F for float, D for double, and their respective minimum bytes. So if you want to access all the symbols, we can use typecodes attribute of array module, which will return a string containing character of each data type. So here beginning from small b up to last symbol D, and their respective meaning and respective Python data type is given in the table. So let's create an array object. So array constructor takes two arguments. First one is a type code, one of the symbol which declares the data type of element which array is going to hold, and second one is a initializer, is an iterable or a generator function which returns the elements of given type, and it will return an array object. So for initializer it must be list or byte like object or an iterable of matching data type. So let's create an array object of type signed integer from list. So here we are providing list iterable containing 10 zeros, and we are creating an array object out of it. Same way we can also provide generator function which will create an array from the elements returned by the given generator function. So it will return from 0 to 10 integers. Next is accessing value. It is very similar to the list data type. So it follows indexes beginning from 0. So same indexes we explained in list, such as positive index and reverse index, it is applied to the array object. So here we have created elements from 0 to 10, and if we try to access element at index 4, it will return 4 because we are storing element from 0 and index also begins from 0. Same way for slicing, if we try to execute slice, it will return slice of an array object. Here as we can see, it works really similar to the slicing we saw for the list. So for more details and examples, check out the list section. So if you want to modify a value at particular index, we can modify it using indexes. So at 0 index, we want to replace that element with the new value. So as we can see here, at index 0, the new value is assigned. Same way we can also replace slice of element, which is similar to the list. And next topic is iterating. It is also works same as we saw for the list. So here we are executing for each loop, which will print all the elements in a separate line. Next is functions of array. First one is len. It is a built-in function which works for all iterable. It returns the number of element held by the given iterable. So if we execute on array, it will return the length of array, which is the number of element it is held by the given array object. Next one is append, which adds the given element to the end of array. So we have array of 0 to 10, and if we execute append 11, it will add new element to the end of the array. Next one is insert, which inserts the given element x at given index I. So we are providing index 5. At index 5 we are inserting element 7. So here at index 5 the element 7 is inserted. Next function is extend, which takes an iterable as an argument. It appends the items of given iterable to the end of the array. So here we are having an array from 0 to 4, and we are extending elements by this iterator. So as you can see, the given elements of iterable is appended to the end of the array. Next function is pop, which takes one optional argument I, which is an index. If that is not given, it will remove and return the last element of the array. So here we are having same array 0 to 10, and if we execute pop without any argument, it will remove and return last element. So after removing, it will only hold 10 objects, which is 0 to 9. So it is mutable data structure. When we are performing any operation, it is modifying an object itself. And for pop, if we are providing an index, it will remove and return element stored at particular given index. So here we are popping at element 5, which is 5, and it is removed from the array. Next function is remove, which removes the first occurrence of a given element x. So if the given array does not contain duplicate element, it will remove the given element. But if there are duplicate element, it will only remove the first occurrence of a given element. So here we are removing element 9. So here it is only one occurrence, so it will be removed. If we try to remove non-existing element, it will give you value error that given element x is not in array. Next function is count, which returns the number of occurrences of given element x inside array. So if we have duplicate element and we want to count exact occurrences of given element, which is here 5, then it should return 3. As you can see, it is repeated 3 times. Next function is reverse. It reverses the order of item of given array. So as we can see here, earlier it was beginning from 0 to 10. After reversing, its element order is reversed. Next function is tofile, which writes the all element to the given file object. When we are writing to file, we are always converting the given object into the binary. So the given file will contain data in binary. So we must open file in binary mode. So here we are opening in write mode in binary. So if we execute it, and here we are providing an object of file, so it will write array from 1 to 10 to the file. Because we are writing to file, it is not giving any output. But if we check the file path, this is the file path, it will contain this element returned to the file. Next function is tobytes, which converts the array object into bytes representation. So the same array object, int array, is converted to the bytes, which can also be written to the file or transmitted over the network. Next function is tolist, which create the list of array. So if we execute tolist, it will return a list of elements which contain same as the elements of given array. Next function is fromfile, which reads the n elements from the given file and appends them to the end of array. So it takes two arguments. First one is a file object, and second one is a n, which is a number of element to be read from file. So earlier we store 10 numbers inside this numbers.bin file. Now we will read those numbers and append to the existing int array, which is holding from number 1 to 4. So let's execute it. As we can see, it is reading 1 to 10 elements from the file and appending to the end of array. Next function is fromlist. It appends all elements of given list to the end of array. But here the type of elements must match the type code given here. So here from list we are providing list inside. It will append the elements of given list to the end of array. Next function is frombytes, which appends the element from the bytes representation. So earlier we converted number 1 to 10 to the bytes. So same bytes object is used here. So we will read from byte, which will append 1 to 10 element after elements 1 to 4. So if we execute it, so 0 to 10 earlier we were converted in this bytes. So same objects are appended to the array object. Next is attributes. So item size, which returns the length of each item of array in bytes as per the local machine's C implementation. So earlier in the beginning we explained the symbols and their minimum size. So this is the approximate minimum size, but if you want to measure the actual size which is on the current machine, we can use item size. So if you want to know how many bytes are used to represent integer on this current machine, we can use in item size on given array object. It returns 4. So 4 bytes for single integer element is used internally for storing. So array behaves very similar to the list. So for more details and example, visit list section. That brings us to end of the video.